Alright, this is your Chapter 3 test review video. So let's get started. It says for exercises 1 through 3, suppose that line A is parallel to B and C is parallel to D. So, number 1, angle 2 and angle 10 are what type of angles? Here's 2, here's 10. What type of angles are those? Well, if you were to move line C down to line D, they would be in the same spot, making them corresponding angles. Alright, so they are corresponding angles. Now, let's look at number 3. It says angle 3, it's supposed to be an arrow. Angle 3 and what angle are alternate interior? Alternate means on the opposite side, alternate sides of the transversal. Interior means inside, between the parallel lines. Well, if you look here, if you compare it to any of these, 3 would be an exterior angle. But if you compare it to these, now they're between lines A and B, and C could be your, C here could be your transversal, making 3 and 7 the alternate interior angles. So this would be angle 7. All right, 3 and 7 are alternate interior. C would be your transversal. A and B would be the parallel lines that you're referring to. All right. Number 3, angles 9 and 8. So here's 9 and 8. Angles 9 and 8 are what kind of angles? Well, again, they're inside lines C and D. A would be your transversal, so since they're between lines C and D, that means they're interior. They're on the same side of the transversal, so they are same side interior angles. All right, 9 and 8 are same side interior angles. Now, number 4, which angle could you show is congruent to angle 11 to prove A and B parallel? All right, so for A and B to be parallel, you couldn't use any of these angles, and you couldn't use any of these. But to prove it parallel, what you could do is if you kind of took this diagram and rotated it to where A and B looked more like C and D, it would be really easy to see that 11 and 9 are corresponding angles, because if you were to slide this over, slide A over on top of B, they would be the same angle. So, which angle could we show is congruent to 11 to prove that they're parallel? The answer, angle 9, because they are corresponding angles. When corresponding angles are congruent, the lines are parallel. All right, so now what relationship between 6 and 11 shows C and D parallel? Well, so here's 6 and 11. In order to get C and D parallel, we know these are same side interior. Okay, we know they're same side interior. But what is special about same side interior? Okay, if you said add to 180, you're good. So what relationship would we between these two would we have to show? We would have to show that the measure of angle 6 plus the measure of angle 11 equals 180 degrees. If we could show that, then C and D would in fact be parallel. All right. So let's go down here to 6 now. So for exercises 6 through 10, suppose A and B and C and D are parallel. So if the measure of angle 6 is 50, here's the measure of angle 6, then find the measure of 11. Well, if you look, we just said it, they have to equal 180. So the measure of angle 6 is 50 plus what is 180? So the measure of 11 would have to be 130 degrees, because 130 plus 50 gives you the 180. All right, now if the measure of angle 2 is 70, what's the measure of angle 6? Now we can go about this two ways. The way I did it was 2 and 4 are corresponding. So that means 4 also has to be 70 degrees. And since 6 and 4 are vertical, that means 6 also has to be 70 degrees. But what you could do as well is say 2 and 3 are same side interior, so they have to add to 180. So since 2 is 70, 3 would have to be 110. And now these two, since they're supplementary, they're adjacent supplementary, 6 would also have to be 70 degrees as well. So you can do it either way, whichever way is easiest for you to remember. Number 8, if the measure of angle 1 equals 130, then find the measure of angle 5. So if this is 130, we want to find the measure of angle 5. Now, what I did, and which is completely fine, 1 and 3 we know are corresponding, so this has to be 130. And since 3 and 5 are vertical, 5 has to be 130. Now, even though these look like we're getting the same answer, from problem to problem, you can't refer back to the previous problems. So just because the measure of angle 2 is 70 does not mean if 8 asked about the measure of angle 2, you could say, oh, it's 70 because that's what it says in number 7. These are completely separate questions. So, and if you look here, if you put a 70 in for here, this would equal 200 degrees. All right, so you can't use any information from the previous problem unless it specifically says somehow to use the previous problem. All right, let me clear some of this ink out of here. Clear ink, scroll down. Oh, don't want to go too far. All right, where were we at? Number 9, I believe. If the measure of angle 7 is 110, what is the measure of angle 10? Well, we know again that these are same side interior, which means they're supplementary. So since this is 110, this measure of angle 10 will have to be 70 to equal 180. Oops, 70 degrees. All right, now if the measure of angle 4 is 45 degrees, what is the measure of angle 12? Well, since 4 and 12 are corresponding angles, this would have to be 45 degrees as well. All right. So now that we're done with that, I'm going to clear the ink and go down to the 11 through 14. Find the values of the variables. So for number 11, z is about the easiest one to find because we know these are adjacent supplementary, so they have to add to 180. So that means z, I'm going to write them up here, x equals z equals. So we know z is going to have to be 30 degrees. All right. Now, let's find x. Well, we know since this angle here, that's x degrees, and this angle here, that's x plus 20 degrees, we know these are the remote interior angles to the exterior angle 150 degrees, which means the sum of these will have to equal 150 degrees. So x plus 20 equals 150 degrees. Simply solve this out. 2x plus 20 equals 150 minus the 20 minus the 20. 2x equals 130. Divide both sides by 2. So x equals 65 degrees. All right, so x is 65 degrees. Now, if you want to check it, you can. This would be 60 degrees. This would be, I'm sorry, 65 degrees. I don't know why I wrote 60. This would be 65 plus 20, which is 85. 80 and 60 would be 140. 5 and 5 would give you an extra 10, bumping it up to 150 degrees. So therefore, both of these are in fact correct. All right. Now let's go to number 12. Let's find x and y. All right. So again, we know that x is an adjacent supplementary angle to the 140, so they have to equal 180. So that means x is 40 degrees. Now y, and this right angle here, which we know is always 90 degrees, these two have to add up to give us the 140. All right, so we know that 90 plus y equals 140. Subtract 90, subtract 90. So y equals 140 minus 90 is 50. So 50 degrees. Now you can double check this because we know these three have to add up to 180. 40 and 50 is 90. Plus this 90 gives us that 180. So both of these are correct. Check marks. All right, now we're down to number 13. We're going to find x and y here as well. X equals, y equals. All right, so now we know that y is the sum of its two remote interior angles. So we know that y is going to equal the 39 degrees plus the 49 degrees. All right. So we know that y equals 39 plus 49, which is 88. So we know that y is 88 degrees. Now, since we know that x and y are adjacent supplementary, all we have to do is take 180 and subtract the 88 from it. All right. As soon as this decides to let me write again, I don't know why this keeps doing this. So you just take the 88, 180, and minus the 88 from it, and that would give you 92. So x is 92 degrees. All right. You could plug it in and check it, and in fact, it would come out correct. All right, now here we have four variables to find. We need to find w, x, y, and z. Maybe not necessarily in that order, but that's what we need to find. All right, so we know that 84 plus w is going to have to equal the 115. So let's go ahead and take care of that. 84 plus w equals 115 minus the 84 from both sides. So that means w equals 31. All right, so w is 31 degrees. Now, we know that y and 15 are adjacent supplementary, so that means they have to equal 180 degrees. So what we would do is simply take take the 180 and subtract the 115 from it, and that would give us 65 degrees. So y is 65 degrees. Now we know y and x are vertical angles, so that means they have the same measure. So x is also 65 degrees. And then z and the 115 are also vertical, so z is going to be 115 degrees as well. All right. Again, you could plug them all back in and check them to confirm they are correct. All right, moving right along. All right, determine whether the following pairs of lines are parallel, perpendicular, or neither. So the easiest thing to do here is remember for parallel, the slopes are equal. For perpendicular, they're opposite reciprocals. And for neither, they're neither opposite reciprocals nor equal. So since this one's in y equals mx plus b form, let's put this in y equals mx plus b. Subtract the 2x from both sides. So y equals negative 2x plus 7. All right, the slope here is 2. Slope here is negative 2. Since they're not equal, they're not parallel. Since they're not opposite reciprocals, they're not perpendicular. So these are neither. All right, so look at 16. Let's do the same thing. Let's get this in y equals mx plus b form, minus the 3x, minus 3x. So y equals negative 3x plus 2. Well, if you're looky here, we have 1/3 and negative 3. So those are opposite reciprocals of each other. So these lines are perpendicular. All right. Number 17. Let's do the same thing. Subtract the 4x. Subtract the 4x. So y equals negative 4x minus 3. Well, slope here is negative 4. Slope here is negative 4, so they're the same. So that means they are parallel. Oops. All right, let's go to the last one. Again, add the 3x. Let's put it in slope-intercept form. So y equals 3x plus 5. So here we have a positive 3. Here we have a positive 3. Since they are the same, that means it is parallel. Again, I don't know what this thing's doing. I don't know why it's lagging. So just give me a second and I'll write it in. Parallel. All right. Let's move down to the last 3 problems now. What is the equation of a line parallel to y equals x minus 1 that contains the point 1, 2? So since we have a point and we know what our slope is, we're going to use point slope form, which is y minus y1 equals m times x minus x1. All right, our m here, since there's nothing written, that means m equals 1, because that's the only variable you can leave off when you're multiplying like that. And then this is our point, so this is x1 and y1. All right, so now what we're going to do is plug into this equation. So we're going to do y minus y1, which is 1, equals our slope, which is 1, times x minus x1, which is 1. And actually I made a mistake right up here, and as soon as this stops lagging, I'll correct it. Come on. All right, here I used the x value instead of the y value. All right, so this should be y minus 2, because that is our y1, which is 2. So y minus 2 equals 1 times x minus 1. You can leave it in this form, or you can change it to slope-intercept form. Since this is just 1 times x minus 1, it's going to stay. It's not going to change at all. It's lagging again. So this is going to be y minus 2 equals x minus 1. Add the 2, add the 2. So y equals x plus 1. That is the equation of our line parallel to y equals x minus 1 and contains the point 1, 2. Number 20. What is the equation of a line perpendicular to y equals 1 half x plus 1 and contains the point negative 2, 1? So again, we're going to use point slope formula. So again, we're going to use point slope formula. So y equals 1 half x plus 1. All right, 1 half is our slope. Slope equals 1 half. This is our point over here, x1 comma y1. All right, so now we just have to solve for the variable. So y minus 1 equals, now since it's perpendicular, we're going to have to take our opposite reciprocal. So the opposite reciprocal of 1 half is negative 2 times x minus negative 2, which will be x plus 2. All right, which will be x. So our equation is y minus 1 equals negative 2 times x plus 2. Don't know why this thing's jumping around so much. You can multiply it through if you want, or you can leave it in this form. If you multiplied it through, your answer would be y equals negative 2x minus 3 if you were to multiply it through. All right, because this would give you negative 2x minus 4. Add the 1 to both sides to get the negative 3. All right, now last but not least, line AB contains the points 2, 1 and negative 1, negative 8. What is the equation of a line parallel to AB that contains the point 0, 2? So first thing we're going to do, we're going to find our slope. I'm going to make this 2 and this 1 because both of these are negative. So remember, our slope is rise over run, so it's y2 minus y1 over x2 minus x1. So let's just plug in our numbers. Y2 is 1 minus -8, so plus 8, over 2 minus -1, which is 2 plus 1. 8 plus 1 is 9. 2 plus 1 is 3. 9 over 3 is 3. So since it's parallel, that means our slope is going to be 3 and contains this point. So y minus 2 equals 3 times x minus 0. So y minus 2 equals 3x. Add the 2 to both sides. So the equation of our line is y equals 3x plus 2. All right, you could either leave it in this form or bring it down to this form. Either one is right, and I'll take both. All right, but just know that this is probably the more common way that you'll see these lines written, but I'll take either one. All right, so that is your Unit 3 review. As long as you understand how to do these 21 problems, you should do completely fine on the test. So remember, the test is tomorrow. Good luck.